Yo, Servus. So, I received this question. It's a very interesting question right now. It's actually from Instagram. So this is a question which is a bit about calculus. So let me show you what I mean. So you have to find a point on the curve, which is this curve, which is nearest to the line of 3x plus 2y plus 1 equals to 0. This is a so-called general form of a straight line, which consists of the constants a, b, and c. So you can use these three constants to build a general form of a straight line. And then you will get this entire thing equals to 0. So there is a very important use, one of the few important uses of having this general form of the equation of linear straight line is to actually get the distance, perpendicular distance formula. So as you know, according to our mathematical thumb rule, if you want to find the nearest point to the nearest point to that straight line, or you can say, well, the shortest distance between the point on the curve and the line. So you must have a line which is orthogonal to the line, and also, well, you can say as the perpendicular distance between the point on the curve and the point on the line. And there is a particular formula which you can use them, which is, so we can name the shortest distance as a small d, or I can just say s. Later you will see why. So s is the shortest distance, well, equals to the square root, no, the absolute value of ax plus by plus c over the square root of a squared plus b squared, where a and b are the constants of the linear straight line equation. So we have a, b equals to 3, 2. So we can just easily calculate the value of this radical. So you will have, in this case, 3x plus 2y plus 1 inside the absolute over, you will get square root 13. We assume that this square root is always positive, so that the solving will be very simple. And you will have this equals to s again. And well, we need to find the shortest distance. So why don't we just think about a bit in terms of the calculus? So we need to find the shortest distance. It's just like we need to find the minimum value of the s. So we can just use the concept of the ds of the certain variable equals to 0. So this is the, well, this is reasonable, because when we try to differentiate a function in respect to certain variable, or maybe just in respect to multi-variables, we can just equate the differential equation equals to 0 with the 0, and so we can get the values of variables which can actually get the minima or the maxima of the s. Okay, now we're gonna use this idea, but first we know that we can go into two paths. One of the paths is we can just solve, well, we can just differentiate in respect to x, or maybe we can just differentiate in respect to x and also in respect to y. But since we are right now, in this case, assuming that we are still studying A levels, okay, or SPM, so we just assume that we are able to solve only for one variable. So we can just substitute y in terms of x, or x in terms of y. In this case, I want to substitute y in terms of x, which is y equals to, well, you can just see from the curve equation, which is this one, 3x squared minus 4y squared equals to 72. You will get at the same time an expression of y in terms of x, which is equivalent to this entire radical. So again, we assume that this is a function of y, so the radical must be always positive, and we have a radical on the top, and this will become 2, okay, which is equal to y. Just substitute this equation. This is we name it as equation 2, and this is we name it as equation 1. So we substitute equation 2 into the equation 1, and so we can just get s in terms of x. And then by removing the absolute value, and assuming that this entire absolute equation is always positive, so we can just get 3x plus 2 square root of the entire expression in terms of x over 2 plus 1, and then over square root 13. And then we can just differentiate in respect to x. Yes, no problem. We can just further simplify it by having this as a constant of s. Yeah, it's okay, it doesn't matter, as it will vanish very soon because of the differentiation. And then we will have here nothing but only just a radical, and then plus 1. And we just try to differentiate them in respect to x. So we know that dx is equal to 0 because of the properties of maxima minima, one of the criteria. And we can just substitute this thing on the left hand side, and hence we will get the square root 13 times 0 equals to the differentiated equation on the right hand side, which is 3 plus 1 over 2 times the chain rule inside times this entire thing, and then this one is minus 1 over 2, and then plus the constant, so constant is 0, and that's all. And then this one will become 0 on the left hand side, and then this one will become 3, this one will become 1, well, half times 6x equals to 3x, and then you will get this entire thing here, and then you are able to solve the well, let me see for a while. Okay, so now we can just try to manipulate this entire equation by multiplying with this sort of radical conjugate of this expression. We just multiply with each single on every side with this. Yep, just multiply on every side with this one, and you will get also 0 times 3 of this entire thing, 1 over 2, okay, because we multiply with this one, and then plus 3x because we have just multiply with this expression with this, with a negative radical, and because they have a same value, so 1 over 2 minus 1 over 2 equals to 0, and if your exponent is 0, then the entire thing must be equal to 1. So now we can just try to solve them by using just a normal, like the normal way. So we can get here x squared, and then 3x squared minus 72, and then 72 equals to 2x squared, and then x squared, well, x, I mean, equals to plus minus 6. So you can just try to substitute that curve from that curve equation, which is this one. Okay, I'm gonna copy here down. So recall back, we have equation 2, which relates the x with y. So we can just substitute one of the values. It doesn't matter because x is already squared, and we just try to get the radical expression, the value inside the radical. So we can get here 3 times 36, okay, and then minus 72, and then the entire thing must be square root. Notice that 72 is nothing but 2 times 36. So 3 times 36 minus 2 times 36, it equals to 36 over 2. And then you will have here 6 over 2 equals to 3. And that's all. Hey, sorry, my apologies. It should be plus minus 6, so plus minus 3 here. Okay, so it's very hard to just directly identify it. Sometimes it's very insensible to identify that if you have x equals to 6, then y must be equal to 3, because you have to consider which point must have a shortest distance to the line, the straight line. So we can make up with 4 pairs. So we have here 6 and then minus 6 on the x side, and then y we have 3 minus 3. So because we have 2 for x and then 2 for y, so 2 times 2 according to the multiplication principle, we will get 4 pairs in total. Okay, and then what are the 4 pairs? So we have 6, 3, and then we have minus 6, minus 3, and then we have minus 6, 3, and last but not least, 6 minus 3. And these are the 4 pairs that we're gonna try it on, because and then we will get the shortest distance. So recall back again, the shortest distance has this formula. Well, we have just got the constants here, so which is the equation 1. So I just copy down back here, and as you can see, I just have included this. So this is the s, which is the shortest distance to the straight line from the point of the curve, and then we can just substitute x, y with one of the pairs, but we don't have just substitute all of them. We can just try to think about the fact that because we have the absolute value on the numerator, so we must also just remember the fact that, well, any absolute value must be positive. Even though you have a very large negative number, it remains a very large positive number because of the property of absolute value. So that means if you have a negative 6 and negative 3 as x and y, and so you have a very large negative number because you only have everything 3x plus 2y. Well, if you try to substitute them with negative 6 and negative 3, you will have a very large negative number plus 1. And 1 is just a very small positive number. When you add a very large negative number with a small positive number, then you will still have a very large negative number. It makes sense, right? So you will have actually the positive number, a very large positive number. Same goes to 6, 3. Yeah, definitely, because 6, 3 are positive numbers, and hence we will have also a very large positive number on the numerator, and hence we will not get the shortest distance. Instead, we will get the largest distance. So we have eliminated these 2 pairs. So left with these negative 6, 3, and then 6, negative 3. Well, logically, we can just actually think that you need to get a relatively large negative number, which is the negative 6, and then substitute on the x, and hence you will get the shortest distance. But you must also think that you might have a large negative number on the numerator when you substitute x equals to negative 6. So why don't we just try on that absolute side? We will have negative 6, 3 in this case. So the absolute value inside here will be here negative 6 plus 2 times 3 and then plus 1. And then you will get eventually, in this case, negative 11. And then you will have here, in case of 6 comma minus 3, and then you will have here 3 times 6 plus 2 times negative 3 plus 1, and hence you will have 30. So consider the fact that we have absolute values here. We have the modulus here. So the absolute value of negative 11 must be equal to 11, and then this one must be 30. So obviously the smaller value gives you the shortest distance, right? So negative 6 and 3 is actually the point on the curve which has a shortest distance which gives the shortest distance to the straight line 3x plus 2y plus 1 equals to 0. And that's all. Thank you for watching this video.